I'm Anil Kumar, and in this video we will try to understand how to sketch graph for a reciprocal trigonometric function. Question here is, sketch the graph of y equals to cosecant 2x. State period of the function. Now whenever you want to sketch graph of a reciprocal trigonometric function, then it's better to start with the primary trigonometric function itself. So you can write this equation as y equals to cosecant 2x equals to 1 over sine 2x, correct? So that is by definition cosecant 2x is reciprocal of sine 2x. So we will begin by sketching graph of sine 2x and then do reciprocal of that. Let's try to understand what is sine 2x. Now sine 2x has a time period of t. The k value is 2, so it will be 2 pi by 2. So it has a time period of pi, right? That means in 2 pi there are 2 sine waves. That's the meaning of sine 2x, correct? As you know, maximum and minimum for sine 2x will be, maximum will be 1 and minimum is going to be minus 1, right? X is a 0 for this function. So let me sketch a sine function first and then we will understand how to sketch graph for cosecant 2x. So what I will do here is I'll roughly sketch, and I hope this will help you to understand at least. I'm not using any graph paper, but I think this will help you to understand it in a better way. And it will also give you an idea that in the test many of the times we have to sketch, right? Or provide a neat sketch. For doing so, this is a good method. Okay, so we have our sine function. Let's say this is the y-axis, that is the x-axis for us, and as we wrote, let this be 0 for us. Now sine function has a time period of 2 pi, but we are now looking into sine 2x. So what I've sketched here is sine 2x, right? So I'm writing sine 2x here. So sine 2x maximum value and the minimum value as we have written, and as you know, is plus and minus 1. So this is plus 1, minus 1, and one period is pi. Perfect. Now, if I have to sketch the reciprocal of this function, which is cos 2x, which is cosecant 2x, equals to 1 over sine 2x, then what we will do is we look into the graph of sine 2x and then sketch cosecant 2x. Zeros will translate to vertical asymptotes, right? The reciprocal of 0 is infinite. So we'll have vertical asymptotes at the zeros. The strategy is same as you learned for sketching reciprocal of polynomial functions, right? So all these zeros on the graph of sine 2x will translate into vertical asymptotes for cosecant 2x, correct? Now, what is reciprocal of 1? Well, the reciprocal of 1 is 1, right? And what is the reciprocal of minus 1? It is minus 1. So these are invariant points, right? So like that. You know, it's a periodic function. So actually, I should have continued like this. And let me draw an arrow here to kind of show you that this is a periodic function which repeats. Okay. Now, as the value of the function decreases, let us say goes from 1 towards 0, reciprocal will increase, right? Half reciprocal will be 2, 1/3 reciprocal will be 3, 1/10 reciprocal will be 10. So it approaches infinity. For the positive half, it approaches towards positive infinity, right? Like this. For the negative half, from minus 1, it approaches towards the negative infinity. Do you see that part? So that is how the graph of cosecant 2x will be graphed. Right, so let me continue like this, right? So that is how it should look like. I hope that very clearly indicates how you can easily sketch the graph of cosecant 2x. Do you see that? So what you will notice for this, that the function, this is one full wave of cosecant 2x. It repeats after pi. Do you see? This is one wave starting upwards and downwards. It repeats after pi, and therefore for this function we have to state the period also. So the period for this function will be pi, as is the case for sine 2x, right? There are other properties which you should also make note of. That is that at pi by 2 multiples we have vertical asymptotes for cosecant 2x. It is positive between 0 to pi by 2, negative between pi by 2 to pi, right? You could write them in general terms. There is a local maximum and local minimum. So, local minimum value of cosecant 2x is 1, which will be at pi by 4, right? And it is local maximum is minus 1, which will be at 1 pi by 4, 2 pi by 4, 3 pi by 4. Right? So I count purposely like this so that it becomes easy for you to work in radians, right? So these are a few other properties which you should look into. Also the intervals of increasing and decreasing. The function is decreasing, then increasing, increasing and then decreasing, right? So at times you may be asked for those also. But our primary objective here was to understand how to sketch graph for cosecant 2x. I think the steps are absolutely clear. Start with sine 2x, the primary trigonometric ratio, and then do the reciprocal of that. All x-intercepts will be translated into vertical asymptotes. 1 and minus 1 will be the invariant points. Interval when the function is increasing, cosecant 2x will become decreasing, correct? Positive part will get reciprocal will be positive. For negative part, reciprocal will be negative. So these are the key things which will help you to graph any reciprocal function, right? So as an exercise, what you can do is, that is the question for you. You can graph y equals to secant, let us say 3x. So if you do secant 3x, then the time period is going to be 2 pi by 3. Okay, remember that. And you have to first sketch the cosine graph and then secant graph, correct? So cosine 3x starting with, and then do reciprocal of that to sketch secant 3x. I hope that will help you. Thank you and all the best.